In this video, I'll be making nitrobenzene from benzene. For this synthesis, we require concentrated nitric acid 68%, concentrated sulfuric acid 98%, benzene 5% sodium hydroxide solution, and anhydrous calcium chloride. To start things off, we prepared the nitrating mixture. For that, I kept a 100 ml beaker in an ice bath. Then 13 ml of concentrated sulfuric acid is added in beaker. Now I add some water to ice to prepare ice bath and let the sulfuric acid cool. To this 10 ml of 68% concentrated nitric acid was added in small portions with stirring. Fuming nitric acid must not be used here. I used it before and I ended up with a low yield of nitrobenzene due to the formation of metadinitrobenzene. Then I placed a 100 ml conical flask in the ice bath and in it I placed 10 ml of benzene. After cooling both the benzene and the nitrating mixture, the cooled nitrating mixture is poured in the separatory funnel and a thermometer is placed in the conical flask. Now the knob of the separatory funnel is adjusted to slowly drip the nitrating mixture into the conical flask containing benzene. The conical flask is shaken and the temperature is monitored by the thermometer. The temperature is kept below 30 degrees Celsius during the whole addition. After the addition is complete, I took the flask out and gave it a vigorous shake. You can see that there are two layers formed. The lower layer is the acid layer while the upper layer is the organic layer. Now I prepared a water bath by heating some water in a 500 ml beaker and the thermometer is placed in it to monitor the temperature. The conical flask is vigorously shaken and placed inside the water bath. Another thermometer is also placed in the conical flask to monitor the internal temperature. The temperature of the water bath is maintained between 50 to 60 degrees Celsius. This is done by turning the flame on and off occasionally. The flask is taken out and shaken at regular intervals. At one point on shaking, the temperature of the reaction mixture started rising above 60 degrees Celsius. So I put the conical flask inside the cold water bath I prepared before, which was kept off screen. When the temperature of the reaction mixture came below 50 degrees Celsius, I again placed the flask inside the beaker. After that on shaking, the temperature didn't rise. The reaction that's occurring is an electrophilic aromatic substitution reaction. The sulfuric acid react with nitric acid to produce nitronium ions, which is our electrophile. This then attacks the benzene ring with removal of H plus ion with the HSO4 minus ion. Thus the sulfuric acid is regenerated and is not consumed in the reaction. It is important not to let temperature rise above 60 degrees Celsius as high temperature would favor the formation of dinitrobenzene. After 1 hour, the flask is taken out from the water bath and the reaction mixture is poured into 100 ml of ice cold water. As on dilution, the density of the acid decreases, the lower layer becomes the organic layer and the upper layer becomes the acid layer. The contents are poured into a separatory funnel but I forgot to close the stopcock. So I closed it and again poured everything into the separatory funnel. Then the separatory funnel is stoppered and shaken to remove any acids in the organic layer. Then the layers are allowed to separate and the stopper is removed. When all the nitrobenzene has settled in the bottom, it is carefully drained in a 100 ml beaker. After this, the aqueous layer is drained into a 250 ml beaker. Nitrobenzene is sparingly soluble in water, and the turbidity in the aqueous layer is caused by it. Then to the nitrobenzene, 15 ml of dilute 5% sodium hydroxide solution was added, and the contents were poured back into the separatory funnel. Again, the separatory funnel was stoppered and shaken to remove any adherent acids. Then the separatory funnel is placed back onto the stand and the layers are allowed to separate. Then the lower nitrobenzene layer is drained out in a 100 ml beaker. The nitrobenzene is cloudy due to presence of small amount of water. So I added some anhydrous calcium chloride and soiled the beaker and stirred with a glass rod. After some time, the calcium chloride pulled any water present and our nitrobenzene cleared up. You can keep this up if you want, but it may contain small amount of metadinitrobenzene that would have been formed, so I will further purify it with distillation. Nitrobenzene boils at 210 degrees Celsius. So over here I have set up a short path distillation setup. The clear nitrobenzene is decanted off in the distillation flask. Then a stopper with a mercury thermometer is placed on the distillation flask. The flask is then heated with a spirit lamp. The receiver flask is covered by some paper towel to keep it cool. Initially, some unreacted benzene came over. When the temperature went up to 210 degrees Celsius, I changed the receiver and covered it with some wet paper towel. For fast distillation, I covered the distillation flask with aluminium foil. You can see some drops falling in the receiver, and the temperature in the thermometer became constant at 214 degrees Celsius. This may be because the thermometer is not properly calibrated. Shortly, the temperature in the thermometer went up to 216 degrees Celsius, and then no more distillate came over, and the temperature in the thermometer fell below 210 degrees Celsius, and at this point, flame was removed. In the receiving flask, we got some pale yellow clear nitrobenzene. In the distillation flask, we are left with some dark brown goo. The final yield of nitrobenzene is around 9.3 ml. That corresponds to a percentage yield of 80%. However, yields up to 90% or higher are possible. Maybe due to washings and the distillation, my yield came lower than expected. I stored it in a glass container for future synthesis. I upload videos every Tuesday, so subscribe to my channel. If you like my work, you can support me financially through Patreon and PayPal. Links are given in description.